Okay, guys, welcome to the second CAD workshop. Today, our plan is to go over some more specifics about the exam and then move into some more complex part modeling that uses some more complex features. So basically, the SolidWorks certification exam is what you're going to want to take to get SolidWorks certified to show that you're proficient in mechanical design skills. And it's called the most basic one is called the CSWA, or Certified SolidWorks Associate exam in mechanical design. So this one is going to deal with your, let's see, there's going to be right here a list of everything you need to know for the exam. And so this is just a sample exam document, but the real exam is going to look really similar to what you see in this document. The first few questions are just some drafting questions that ask you about your general, like, what is this view? What kind of feature should we use here? So those are going to be more like multiple choice questions. But the majority of it is going to be part creation questions. So you'll have a few basic part creations and modification questions, 2 questions of 15 points. For these, you'll have to show your competency in sketching, extruded features, cut features, and also be able to modify key dimensions. Then you'll have 2 intermediate part creation questions where you're going to have to, again, sketch some features, but you'll also have to show your ability to revolve features or create circular patterns, or maybe even other pattern features. And those can save you a lot of time so you don't have to create the same sketch over and over. And finally, you'll have 3 questions on advanced part creation, where you'll have sketching, sketch offsets, more extruded cuts and boss features, and you'll have some more difficult geometry, which we'll be showing you some examples today. Now, we haven't gotten into assemblies yet, but that's when you take multiple part documents and you put them together to create one you take all the parts and you assemble them into one document. And for those, you can use different mates to connect the parts and to show how those parts are related. So in total, there's 14 questions, and you get 3 hours to take this exam. Let's move into some of the, let's look through the rest of the document. So this is just a practice exam. There's a virtual tester client that you have to download, but this exam is free. So if you would like to, you can download the client and you can take the practice exam. And they tell you if you can get at least 6 out of 8 questions correct in less than 90 minutes, you should be ready to take the real exam. So I probably won't go into the specifics of taking this exam because we're still learning for how to model all the parts and stuff. But if you're interested, you can view this document and it'll detail everything you need to know about how to specifically install that software and get ready to take the real exam. Let's see. Basil, am I missing anything? Or should we move into some of the parts?
Yeah, I mean, I think that's a good overview of how the exam is going to look like, and we're going to go over some of the questions, or we're going to go over the practice exam, some of the questions in the practice exam, and if you, I'll share my screen now.
Okay.
So today we're going to go over part 2 of this exam, which is modeling a a model. And this model, if we can look over here, there's like variables C, B, and A. And if you scroll down a little bit more, it gives you the values of C, B, and A. So what this basically means is that these variables, they want these to be variables, meaning that you can change them later in the design. And if we go over, if you just look at what a value is, right? A value here is 81. If you scroll down and we look at the second question, uh, question number 4, it will give you new values for A, B, and C, and it will ask you for the overall mass of the whole model. And this is generally how things are in the CSWA exam. Uh, you basically enter the value of the mass of the model that you're designing, and of course they give you the material and the density and the values that you need. And we're just going to go over this one specific model. And so to start, you open SolidWorks, you click new file, part, click OK. So now what we're going to do, we're going to start with this sketch. It looks, that's how it looks to be, done. Start with the sketching it. So we go to front plane, we go to sketch, it goes to the normal view, which is what we want. And then where do we want to start? I'm thinking of starting at this specific point right here. So I'll just draw a general, shape of how the model is going to look like. But before we do so, we need to check that we are using the same units as the model. So if we scroll down, it says the unit system is mass millimeters, grams, and seconds. And if you go to SolidWorks over here, you click that, you can see that it's in millimeters, grams, and seconds, which is exactly what we want. Make sure you're always using the same unit system because it might mess things up in the later. If we just go back now, go to sketch, and then go to line. I'll scroll up here. You can make the first angle, and I'll click. Wait, okay. So I just wanted to mention this to be somewhat close to it because I don't want to dimension it and have uh, errors in the future. So if I go to, if I just go to normal view, yeah, that's why it was messing up. Give me 1 second. Let me go back. I'll delete this. So make sure you're always in the normal view of the sketch. It'll make things easier. So I'll start with making this one line and then making the general view. And a cool trick is that if you want to change from a line to an arc, you can just go back and like swing it, and it generally works. And if you can see here, there's two different arcs. Oh, sorry, there's one arc. There's this one line. It gives you the angle, and there's one arc. So this is not correct. We gotta delete this. We make a line, and then we make an arc. So if we move out of the way, it shows us a line. If we go back and then we swing, it changes to a circle. Um, However, it does not seem that we can get a general, shape of that. So what we're gonna do is we're gonna exit. We're gonna go to an arc. We're gonna do a 3-point arc. Basically, you can click on the endpoints. So I want one right there, one right there, and then I can give like a general radius shape, and this looks like how it should look like. So I click over there, and then I basically get the other general model, how it looks like. Please don't mind my cat. He wants some attention. I'll give him some attention later. Give second part over there. That looks right. That, and then the last line. Whoops. There we go. All right, so now we have a general shape. Now we need a dimension. So if we look over here, we can start with from this side, I would say. That's how I would want to do it. So I would select this line and this line, and I would dimension that. And this dimension is going to be 32. So we're going to do 32. And then we're going to dimension the distance from this point to this point, which is going to be 7. Dimension the bottom part as well. So this point to this point is also 7. And the angle between this and this is going to be 45. You can use a chamfer tool for this one, for these two, but right for now, I'm just gonna do this. This is one way you can do it. There's other ways. It's going to be as well 45 degrees. Awesome. And then I'm gonna do the 14 over here, which I'm gonna select this point and this line and drag it up. And this is going to be 14. And then I'm going to do this angle for this line. So I'm going to select this line, and drag it out. And then as we look over here, it's going to be 10 degrees. So this is going to be 10. Awesome. And then, I mean, as we're going, you can see that some of the features are getting messed up, kind of, and it'll basically iron out once we get to it and we actually dimension them. But for now, we're just gonna keep going with the general like how it looks like so far. So if we look at this radius, this is going to be 19 for this arc. So if we do this, give it a dimension, give this 19, and we click enter, and now it dimensions it. Now, if you look over here, this symbol is basically means tangent, meaning this arc and this line are tangent. And if we exit out of Smart Dimension and we click at this arc, and then hold Shift and click this line, we can see that uh, the let me select this right. Okay, if we click this arc and then this line, we should have a relation, and it doesn't, it's not showing up. Okay, let me try this. So it's not showing up, the tangent relation is not showing up. So what I'm going to try to do is delete this arc, and I'll say yes, delete with that. I'm going to click on arc, and I'm going to select this point and select the other point, and I want to try to make it so that it's not so tangent, and then I'm gonna exit out, select uh, select the line, click shift, select the other line, and then now we can see that the tangent is an option. I guess it's because how I sketched it the first time. I sketched it with a uh in a way where it was already tangent, but if it was not tangent, you do that and you click tangent, and if you can see now you have this symbol where that shows it's tangent. And then now we can go to Smart Dimension and give this a radius of 19. Wait, just give me 1 second. 1 second. Let me just, for my cat. All right. Okay. So after we did this arc, wait, we moved it from the normal view. What am I doing? Okay. Okay. Let's move SolidWorks to the side. Make it larger. Okay. Back to the view. All right. Okay. So now we want to dimension the other sections. So we'll go Smart dimension this whole length. So we would select this point, and we would dimension that to be 29. So easy, 29 equals. And then we would dimension this angle to be 45. 45. Enter. and then we would dimension from this line to this point, that will be 5. Click enter. All right, it's getting there. We're getting the shape that we want slowly but surely. So then we're going to do this 24 now. We go to click this point, click enter, like 4, enter, and then we have to do uh so this arc, if you look over here, this arc right here, it shows that the center of the arc is uh collinear with this line. So what we would do is we would first exit out of smart dimension. If you can look at it, you can kind of drag this out. And what you can do is, wait, let me first give this uh, bigger radius. Let me just give it 29 so that can actually give it the shape that we want. So if you see here, it kind of messes everything up. What we can do is we can fix it by making this arc a lot smaller. And this arc is going to be 5, radius of 5. So that's what we're going to do. And it gives a general view again of the model, but we can see that there's a sharp point here. However, when we look over here, it looks tangent, and that's what we're going to try to fix. So if we exit out of smart dimension, we select the arc, we hold shift, we click this line, and we get the add relations to make it tangent, and that's what we're going to do. It is tangent, however, it's pointing the other way. So what we're going to do is first, to fix that, we're going to delete it, try to move the arc so it's on the other side, by first moving this, wait, moving that, yes, like that. And then I think what would make it a lot easier if we can stretch this down, and this is where we're gonna come to this B over here. So let's get this variable B, and what we do here is that we call this a global variable, meaning you can change it anytime, anywhere in the uh throughout the SolidWorks, models. And what we can do is just start it by doing a normal dimension, and we can click the left click, and then when you get to this page, what you would do is you would say equals to, and then in quotes, double quotes, you would say like you give the variable its name, and I'm going to give it A because, I mean, sorry, B, because that's what it is shown in the model. And when you do that, you're going to see the symbol, and if you just hover over it, it says create a global variable, and that's exactly what we want. So we'd click OK, I mean check mark, and it gives you this message, create a new global variable named B, and that's what we want. So we click OK. And if now you look at it, you're going to have this sigma symbol, and this basically means that it's related to an equation or a global variable, that is exactly what we want. And if we look at the manager tree, now we're going to have a new folder that is just called equations. And if you right click it and then you click manage equations, now you're going to see your global variable that we made, and its value, and it's how much it is. And if we look at this model, if we scroll down, it's going to give us the value, which is going to be 57. So what we're going to do here is we're going to change this to 57, click enter. And then if you look over here, it automatically updates the model to be 57, and click OK. So now if we move back to it, we can look at this, like, exit out of smart dimension. We can look at this situation over here, and we can still move a lot of parts, and we need to start basically defining or giving the dimensions and relations. So what we'll do here is we'll start with giving this line and this line being tangent, and now they're tangent. And then I'm gonna move this arc, move it to somewhat how it's gonna look like, this is kind of what it's gonna look like. So that's good. Now I'm gonna give this and this arc, make them both tangent, because this is what this symbol is telling us, that this arc and this arc are tangent. So I'll do that. So now they're tangent, and we can see the relation symbols, so that is okay. And then what we can do here is we can select this line, this point, and so hold shift, click this line, and we can say that they're both concentric because how it looks over here is that it's on that line. So we click concentric, and now it gives us that symbol, which is exactly what we want. And now to finally finish dimensioning this arc, because it's still in blue, meaning it's under not fully dimensioned, we can click the smart dimension and dimension the height relative to this point. So we can click this point and click this line, and we can drag it out to the right side, and we click, and this is going to be 19. And now it looks a lot closer to what it's going to look like. So there's still more features that we're going to just now button up. So if we do this 29 over here and click this point and click this point, drag it down, this is going to be 29. Awesome. And then we're going to do this 19 over here. So we select this point, line, sorry, this line, click, this is going to be 19. All right. Okay, now it's getting a lot closer to what we want. And now, for some things that I'm still missing, because from the overall shape, we still have to do this hole, but I just want to get this over outside shape first done. So with this is still light blue, and what are the dimensions I'm missing? Let's see. Oh, I'm missing A and the whole dimension. That's what I'm missing. So okay, let's do that. So we'll select this edge line feature, select the other side, and bring it down, and we'll do the same thing we would as what we did for the global variable B. So it's a equals to double quotes A and double quotes, and then you see that it gives you this symbol, which is if you hover over it, it says create global variable. You click OK. It says this. Yes, we want to create it. And then we click OK dimension. Then if you go to equations, right click, manage equations. Now we see A. And if you go to the document, it says A is 81. So we change this to be 81. We click enter. And now it updated it. And we can see that everything is given in solid uh, black lines, meaning everything is fully defined. And if we look over here, it also tells us it's fully defined. Now we just want to do this hole at this point. We don't, you can extrude it and then do the hole in an extra step, but let's just get it over with at this stage. We can create a hole, a circle, somewhere at that region, click OK. We can now dimension it. So if we look at the model, they dimension the center relative to this line edge segment and then this segment. So that's what we're going to do. Select the center, select that, and then give this to be, this is going to be 14. Enter, select the center, select this, click over here, give this 14, click N. Oh, this is 24. This is 14. And then, so now we have to give the radius. So the radius is going to be 14 as well. Oh, that means the diameter. So this is going to be the diameter, 14. Click enter. And now we have the model, the same shape that we can see from the practice exam. And now we can finally extrude this feature. So first I'm going to click OK, go to features, extrude, and then it's going to give us, it says that the extrude length is going to be a global variable C. So we're going to do the same step over here. So we're going to say equals to, and then double quotes, C, close quotes, and then you get to see the same symbol again. And then we're going to click OK. This is create a global variable. Yes. And we can edit change the global variable to be what we want. So over here, if we look down, it says it's 43. So that's what we're going to say. We want this to be 43. And you know that you're editing also the global variable because of the symbol. Uh, and yeah, we click enter and it extrudes to how we want it. If you go to equations, right click equations, manage equations, you can see A, B, and C, and they're all the values that we want over here, which is exactly what we want. So now finally we have the model, and if you are able to reach this step, then congratulations. This is actually a relatively difficult problem to get all the dimensions and relations correct. And now if you want to actually answer this question, what we want to do is add the material of steel AISI at 1020 steel. And how we do this is if we look at the manager tree, it says materials and then not specified. So if we right click it, and there's the first option is going to be edit material. We click edit material, and then give it a second. It opens this window, and then we just have to find this steel. So over here it says AISI 1020 steel. Uh, there's two options. So what we should do is if we look at the density, it's 0.0079, and then grams per millimeters cubed. And if we look at the density for it, for example, this one, what's the mass density? So this is kilograms per meters uh, cubed. And if we scroll down, does it show the other options? No. Okay, if we look at this other one, yeah, they're both, this one is not going to be the same density. So we know that it's not this cold rolled, but it's just this one because this is the correct density if we just convert to units. So we click apply, and then we close it. And now if we look over on the side, it gives us the material. And then if you look at it, it just gives us a different color to it, right? Meaning that it's like given a material and it's steel. And now it asks us what is the overall mass uh, of the whole part. So to check the mass, we go to the evaluate tab and then just click mass properties. And if we go over here, we can look under mass, it gives us mass equals to 939.54 grams. And if we go over here, we can see that it is exactly 939.54 grams, which means that, you know, it's pretty accurate compared to what we did. And it also gives us a hint, right? If you don't find any option that is within 1%, please recheck your model. And they generally give us, very exact values. And uh, this is this is what probably, if you don't get the same exact value, you probably did something wrong. Or so make sure to go back. And if we go check the answers aren't on all the way in the bottom. Uh, just to make sure. So we got D for it, which is the correct answer for 3. So if you're able to reach this point, then congratulations. This is actually a pretty, again, hard problem. And to basically, yeah, we finished question number 3. And then if we look at question number 4, it says that we use the same part of the previous problem, but we modify the following parameters. And it gives us a new value for A, B, and C. So this is where the equations come in handy. You can just right click equations, manage equations. We can change A to be now 84. And then we can change B to be 59. 59. And then we can 59 units, and then C is going to be 45. So we'll change 45. And we can click OK. And if you saw the model move a little bit, meaning that it updated, but however, if you're not sure if it updated or you did not see any changes, you can click the rebuild button just to like make sure that everything is being applied. And then here you can go to mass properties and check the mass, and this is the mass. And for this specific question, it's not going to be a multiple choice question. You have to manually enter the value, which is, and when you take the exam, and that's how they can check it. It's not going to be as a multiple choice as this one. And then if we look at the next part of the exam, they use the same model. However, they do some changes to the model. And this is, I'll let Dan go over the second part of this question, and we'll finish this section of the practice exam. So yeah, if you want to take over, Dan.
Yep, sure. Okay, so we've got the part modeled from the previous question, and the dimensions should also be updated to 84, 59, and 45. So we can go ahead and do the next question, question 5, which also builds upon this model. So as you can see, a lot of the questions do build upon each other, which means it's important that you get the correct answer the first time through. And if you set everything correctly with your global variables and stuff, it should be really easy to continue on to the next parts as we saw. So let's go ahead and try to modify this part to make it look something more like this. I can start off by just arranging my view and just looking at this isometric view. I'm gonna want to make this match with this view I see right here. And what I see, the first prominent feature I see is that we have a big extruded cut right on this corner right here. So one thing we could do is we could go from the top view and sketch a little rectangle to cut through the part here. I'm gonna sketch on my top plane and click sketch. Looking here, it looks like it went through the part, but that's okay because we can still draw our rectangle here. We'll start at the, let's see, we could start at the corner here, go up like this, and we can dimension this to be 19. And let's see. So we're also going to need a dimension right here for how far in we're going to want to cut. It looks like that one has the edge of the cut 52 units away from the right-hand side of this part. So I'm going to dimension this side right here to this line right here, if I can, or a point right there. Those will be 52 units away. And the rest of this should be filled in, like this dimension right here, we don't need to dimension because it should be filled in by just subtracting the A value from end 52. Okay, so let's see. So we can go ahead and we can go to features and then extruded cut. And we're going to want to go through all on both sides. So that means we don't have to mess with like any dimensions of how far we want to cut. We just make sure it goes through the whole part. And let's go ahead and do that for both sides and check our view. So it looks like that is looking good. It's starting to match up. And if we highlight this face right here, we can see it looks quite similar to what we have right here with this little lip. And we can see that's kind of the geometry we're going for. The next big feature I notice is there's this hole right here that's going through the part. So in addition to this one, we have a hole that goes through here and also a big gap right here, but we can add that one in afterwards. So since the hole is a bit easier, I'm going to start by creating that geometry right there on this face. We'll go ahead and go normal to this face, and we can create another sketch on this face. And now we'll just create a circle. The diameter of the circle is going to be 11 millimeters. And the dimensions will have 14 millimeters away from this edge. And it'll be 14 millimeters away from the top edge. So we'll set both of those dimensions. Looks like it's fully dimensioned, so we can go ahead and exit our sketch, go to our extruded cut, and it does look like it goes through the entire part. So I'm going to go through all on this one. I don't have to go through all on both because we did start this at the edge of the face, started this at one of the faces, as opposed to starting it in the middle or the mid plane. So I can just go through all in this direction. So we've got that hole now. And we're also going to need this sort of, if we look on this view, it details us our section view that shows what this area looks like, this cutout area. And we can also see a side view of this area right here. You see that it goes, it kind of looks like just a flat plane on this view, but we can see that it's really a curved surface, which means we're going to want to create a cut that's sort of offset in here. Now we can't just create a sketch on this face or on this face right here. For this, we're probably going to want to sketch, use an offset sketch plane of some sorts. So one thing I can do is I can create a mid plane right here and create that feature in both directions. Another thing I can do is I can see I've got a dimension that says it's 12. The feature begins 12 units away from this edge. So I could even create an offset plane, sketch it on that plane, and then continue to extrude 24 units in this direction. I think that's what we'll do for this one. So an important thing to know is that you can create this sort of offset reference geometry. I'm going to go to Tools. Let's see where it is. There should be an option where we can insert sketch geometry or create some sort of geometry. Don't quite remember where it is, but another thing we can do that's actually a shortcut is we can select this plane. We can, we should be able to, let's see, which plane is this? So this is on our front plane. One thing we can do is we can press Control and then left click, and we can actually drag while selecting one of these corners, and it does create that reference plane for us. So there's actually no need to even go through all the menus. But actually, if you wanted to do it with the menus, you could do that as well. You'd go to Insert, you'd go to Reference Geometry, and then Plane right there. So either one of those works. I'm going to use it with the menu. I'm going to click my back face as my first reference. Notice that my plane's going in the wrong direction, so I'm going to flip the offset. And I'm also going to make sure it's going 12 millimeters into this part. So now that I've created that reference plane, I can begin sketching on it. I'm going to go click on that plane, click Sketch, and I'm going to go normal to my view. It does look like we're kind of sketching on this outer face, but it is going to be sketching inside this plane, which I'll show you. So one view that would probably be helpful for us is going to be this section view that they gave us, because we can clearly see what's going on inside here. It looks like our arc looks like it's collinear with this line, or at least the center point of that arc. So I'm going to try to create an arc here. Or one thing we can even do is just create a circle, because I guess you can see it won't hurt to cut into this empty space. And if we ever needed to, we could trim this circle. It just looks like it's going to be easier than creating an arc in this case. Let's see. So this arc is going to have a radius of 41. So the diameter should be twice of that, which is 82. Now the center point of our arc is going to be collinear with this line. So let's see if we can create that dimension there. I'm going to select those 2 points, and I'm going to make them vertical. So it looks like I can only slide up and down now. And it looks like this edge right here is going to be 36 units down. So let's see if we can create that dimension. So in this case, I'm thinking we could probably, let's see. Let's see if we can dimension this right here. No, that'll dimension to the center of the circle. Okay, so we can probably go ahead and trim this arc. I'm going to create some lines right here just to trim this. And now we can delete our reference geometry. And we can see that we can kind of make this point coincident with this line, which should make things a little bit easier to dimension, because as you saw, we previously couldn't dimension to the circle. It would just default to the center of that circle. But now we can refer this point and this top surface and make that a distance of 36 millimeters. And it should put that right into place where we want it. And we've still got this extra distance right here. We might be able to trim this. So let's select this line right here and this line right here. Trim those entities. Okay, so that's not going to work. Okay, so let's, we are going to need to close this sketch somehow before we extrude it. And it looks like, let's see. I'm going to want to keep it as an arc. But one thing we can do is we can follow the same geometry that we're seeing right here. Let me see. One thing we might be able to do is we can select these entities, these lines right here, that are kind of outlining our geometry. And we can convert those entities. So as you can see, if I press this line right here, there's a button that says convert entities. And it will actually draw the same geometry, but now into our new sketch plane, as you could see. I took this line right here and I converted it into the current sketch plane. So now I'll have an outline of the exact geometry that I actually want to cut out. So if I section this, you should be able to see more clearly that geometry being created. Now I should be able to trim to something. So I can select trim entities. I can trim off this excess on both the top and the bottom. And I should just be left with this shape, which I can now extrude. So I can exit my sketch. I can go to my features and I can make an extruded cut. And if we recall, that was a distance of 24 millimeters going in this direction from this offset reference plane. So I'm checking the direction looks good. We're just going to need to change this dimension to 24. And it will extrude like so. Let's just check with our model. It's always a good idea to check with our model and make sure. And it does look like that's the correct geometry. So I'm going to go ahead and continue working on that. I'll just hide this plane temporarily. You can right click on it and press hide. Should make things a little less messy here. But it does look like that geometry is working fine. It looks like, if you look at our side view, that one looks kind of incomplete. Because now we can see we're missing this box right here that was cut out from this corner. Otherwise, it looks pretty good. But let's see the dimensions of that box. It looks like it's got a width of 19 along this dimension. It cuts through the whole part because we see there's nothing else left through there. And it also looks like it's got a height of 19. It looks like it just is flush with this current surface right here. Let's go ahead and go onto our right plane and create a new sketch for that. It looks like we'll go 19 in this direction and along the width. And the height should also be 19 units. So really we're just cutting out a square from here. That's a pretty simple rectangle. We'll go ahead and exit the sketch and enter extruded cut. And we'll make sure to go through all It looks like we should go through all in both directions because our right plane wasn't exactly on this surface, this edge of the part. So looking at that, looks like it matches from this side. We can go ahead and check our other views. Let's check the isometric view. And it looks pretty close to, yeah, this one looks pretty close as well. We can also check some of the other ISO views. I notice we have this one, that looks good. And finally, we have a view from what looks like the bottom. Looks like it's maybe from here. That one looks like it matches up as well. So if you're ever confused about the geometries, you can look at these ISO views and it should give you a sense of whether you're doing it correctly or not. Let's check and see. I think that was it for that part. So let's go ahead and see the question. Says, modify the part in SolidWorks. What is the overall mass of the part in grams? And we also want to change the following parameters, it looks like. So that's where the equations come in handy. We don't have to go back into the sketch. We don't have to change those manually. We can just go into our equations, manage equations, and we'll set those global variables. A will be 86, B to 58, and C to 44. Should update automatically. And we can now go and find the overall mass of the part, which when we go to our evaluate tab, mass properties, let's check the answers here. Number 5 was 628.18 grams, and that's exactly what we have right here, 628.18 for the mass of this part. So it looks like that one is all good.
All right. So this sums up this workshop, and we did two models pretty much, and this is a relatively difficult model, so it might have you guys might have some trouble with these models. If you do, make sure to contact us at Discord, me or Dan, and we'd be happy to help you with anything. And to close this workshop, next workshop, we're going to be going over assemblies and modeling assemblies, and we're going to continue finishing this uh, practice sample exam. And by the end of it, by the end of next meeting, you guys should have all the tools to learn all the tools needed for the SolidWorks S CSWA exam. And after that, you only need to practice and keep practicing, just sharpen and polish the tools, your know-how in these tools. And yeah, hopefully you guys can be very good in it and take the exam and pass the exam. And thank you guys for coming, and we'll see you in the next workshops.
Yeah. All right. Thank you guys.